yet. It's tomorrow.
Tomorrow, okay.
Yeah.
So, on behalf of our department, behalf of our institute, madam, thanks, sir, for coming and join with us.
Thank you. So, you want me to start now?
So within 3:30 actually, sir, our program will start. Okay. Our principal madam, our IIC cell president and vice president, all are joined, and then program will going on. Okay. Not audible, sir, your voice. No, sir, not audible, sir. No, sir. Your sound is not coming, sir.
Sir, it will be better you join through phone. Am I audible?
Sir, you present your presentation with laptop, but you connect another device. If you can connect your mobile, so it will be better. Yes. Hello.
Is it the voice okay now?
Okay, sir.
All right.
Yes, sir.
Okay. It is
All
okay
right.
now.
Okay, thank you. Oh, again problem. Oh, how is problem now?
Sir, your voice is not audible. No, sir, you are not audible.
आपने कहा
No, sir, not
Sir, your voice is not audible still. You are not audible. I think that there is some problem is.
Hello, hello, hello.
This conference will now be recorded.
Sir, now you are audible.
Okay.
Yes, sir.
Thank you. Yeah.
Now you
all
are audible.
Okay. Yeah. Thank you.
Shumanabu, can we start our program or wait for some minutes?
So it will be better we just wait for 2 or 3 minutes. Okay.
Okay, okay, sir.
Amitabh sir, can you start the program? Am I audible, sir?
Yes, we can start. And Alokita ma'am is there?
I think that she is not here.
Okay,
This
very good
conference is
afternoon
no
to all of
longer
you.
being recorded.
Actually, I'm
This
having some
conference-
reason I'm not able to switch on my video. So I would like to welcome all the today's event, all the faculty members, all the members of the IIC, SVIST, and all the students of engineering and the management domain to this occasion of, or a rather we should say a workshop on patent and prototype validation, patenting and the prototype validation. So whenever, as we have discussed in our earlier session, that the startups founder, whenever they will be approaching with their product or services, ideally they should be ready with the prototype. Now probably this prototype terminology would be a little bit newer to all of you, all the students. So that's why we are having two of our eminent speakers today. All the speakers will be introduced by our the president of the IIC cell. So we are looking forward to it, to this particular session. Definitely it will be a knowledge enriching session for all of you. So again, I am thankful to all the speakers and all the delegates for participating in this session. So I would now like to request Dr. Shumon Das, president of IIC cell of SVIST, to welcome the guest and welcome this and inaugurate this session.
Thank you, Amitabh sir. So, good afternoon to all of you, respected principal madam, honorable speakers, vice president, convener of IIC cell, distinguished guest, and all members of the
Shumon
IIC
sir, your
cell,
mic is off, I guess.
dear colleagues. Hello, I'm audible. Hello.
Yeah, yes, audible.
Hello?
I think.
You're audible,
Audible
sir.
to me.
Hello.
Audible, sir.
Yeah, audible. Yes, please.
You are audible. You are audible.
And dear colleagues and dear students and participants. So I welcome you all on behalf of the
Shumon
entire
sir, your
IIC
mic is
cell.
off. You are not audible.
Hello, now am I audible? Hello.
Yeah, he's audible.
Yes.
Yeah.
Yes,
Hello.
sir. Yes, audible.
So on behalf of the entire IIC cell of Swami Vivekananda Institute of Science and Technology, so it is a great honor and my personal pleasure.
Shumon sir,
And
I
it
guess
is
you
a
are not audible.
AG sir, he's audible continuously. We can hear him.
Sir,
Sir.
you have a problem.
Can you hear me,
Am I audible?
AG sir? Yes, yes, you are audible. I don't know, some problem
Yes.
maybe there. AG sir's system. Okay.
So it is a great honor and personal pleasure, and it is a great privilege for me to welcome you all in the occasion of session of prototype
Others are
validation.
able to hear. I'm not able to hear Shuman sir actually. Shuman sir, can you hear?
Amitabh Babu sir, Mohan Babu is audible, no problem, no problem, Amitabh.
Shuman sir, I'm not able to hear you. I don't know. I mean,
Actually, your audio problem is there, okay?
Okay. Now it is a great honor and personal pleasure, and it is a great privilege for me to welcome you all in this occasion of session on prototype validation.
Ataur sir, can you hear us?
Yeah, I'm hearing you. Yeah, I'm hearing.
Now, the session on prototype validation, connecting prototype into a startup under IIC SVIST. Now, I am also very pleased as well as proud to announce you that Dr. Muhammad Ataur Rahman, Professor IIUM, Greenback Campus, of Engineering, Malaysia, and Mr. Pradut Banerjee, the advocate, proprietor of Banerjee Law Chamber, are present among us and will spend their valuable time to share their valuable ideas, thoughts, and experiences. The glorious presence of these two eminent speakers enlightened this session as well. So a heartiest congratulations to both of you, sir, on behalf of the entire IIC cell. Prototype is a scaled down materialization of an idea or product, which allows you to test and validate its feasibility, that is the technical validation, desirability, that is the design validation, and the viability, that is the business validation. The main purpose of creating prototype is to validate the idea or the product, confirming with solid evidence from testing and experimentation that the idea will work before investing the time and the money to convert it into a real product. Prototypes come in the different shapes and sizes. That is the simple paper poster, 3D printing, service role plays. So these are the types of prototyping. Now, prototypes are essential tool to help us uncover the truth behind the potential of the ideas and test if the assumptions are directionally correct. It is nothing but a powerful way to prevent us from wasting our investment. It is also important to note that using prototype isn't key for the start of a new business or the product. They are something that we can put into practice throughout all phases of business. Now the question comes, what are the benefits of prototyping? It is relatively inexpensive to do, gain a better understanding of the problem, learn about how the idea is perceived in the market, increase the chance of getting investment, prevent from the wasting the investment of the wrong idea or features, have more clarity on technical needs and how to build fast, reduce the risk for failure, and get commitment from customers. Now, prototype validation comes in when we have determined what user problem we need to solve, but we have not yet figured out how to solve it. It is a later stage of concept testing that allows us to evaluate how someone feels about a new product before we release it. Product validation is a critical first step for building any new product or business. It benefits the entrepreneur, the company, the team, and the customers. So, we are proud to announce you that two eminent speakers, Dr. Rahman and Mr. Banerjee, and their presence enlightened the session as well. They are rich enough in knowledge and experiences in this domain. I am sure that the web-based session on prototype validation, connecting prototype into a startup, must sparkle and also boost the young, energetic aspirant minds. With these few words, I once again welcome you all and wish a grand success of the entire session. Thank you. Now I would request Somnath sir to introduce the Rahman sir.
Thank you, Shuman Babu. I personally know him very well. Professor Dr. M.D. Ataur Rahman is a faculty of Department of Mechanical Engineering, International Islamic University, Malaysia. He obtained his bachelor degree from Chittagong University of Engineering and Technology, Bangladesh in 1991. He obtained his Master of Business Administration with the specialization of Techno Entrepreneurship from the University Technology Malaysia UTM in 2000, and again in 2001 he obtained his Master of Engineering from Automotive Engineering, and he was completed his PhD degree in 2005 in Automotive Engineering from the University Putra, Malaysia. He is the Fellow Institute of Mechanical Engineering, IMechE, UK. He was the visiting fellow for designing automation system for off-road vehicle at the Mechanical Engineering Laboratory, the University of Tokyo, Japan, from 2005 to 2006. He is the chairman of IIUM Center for Excellence of Electric Mobility. He is also the chairman of IIUM flagship project entitled Innovation of Electric Coaster Sustainable Campus in 2019. He is appointed as the chairman of a IIUM flagship project entitled Electric Coaster and Innovation Ultra Fast Renewable Energy Powered DC-DC Charging Technology of Electric Vehicle. His actually research interests are green transportation system, EV, HEV, intelligent evaporative thermal management system for EV, electric vehicle battery, intelligent powertrain for hybrid and electrical vehicle. So he is the expertise of electric vehicle, intelligent steering system and transaction control system, electromagnetic CVT and autonomous electromagnetic second speed gearbox, automation fuel cell, hybrid electric off-road vehicle, autonomous electromagnetic braking system, and organic structural photocapacitor for EV towards energy independent. And he is an editorial board member of Journal of Advanced Mechanical Engineering Sage publication. He has published within his own credential 150 index journal articles, 4 books and 8 patents. So one notable book is Green Transportation System. So, thank you, sir. So, within a short introduction, now you can carry on your speech. Thank you, sir.
Okay, thank you for introduction. Now, how can I start my presentation over here in your website? I am not seeing any option.
Mr. Dhruvo, please help sir for presenting his presentation.
Hello? Yeah, how can I start my presentation, please?
Sir, first minute, sir. I'm making you the presenter. After that,
Okay.
you can present.
Okay, please.
Okay, sir. You now you can present. I hope.
Thank you. I'll share that. Um, I couldn't find it. What is it, please? Show me again.
It is visible, sir.
No, it is showing that the page is coming over here, but why my?
Sir,
I can show my slide here.
you will find a option with share.
Oh, more option.
Inside the
What is it inside
camera, you will find the option of sharing.
um, I think difficult. How can I commit? Actually, I'm not getting. I don't know. I should go to the right button, right? Or the menu bar, please. Hello.
In the sir, in the bottom of your panel, you will find a button with share.
Uh, yeah, but I don't know.
Sir, your desktop is visible, sir. Just open your presentation file.
Okay.
Your desktop
You
is
can see
visible. Yeah.
You can see
Now
the.
it is
Yeah. Now
Yes, yes.
now you can
yeah?
use F5 for the full screen.
Okay.
F5 for full screen.
Something coming.
So press F5 for full screen, sir. F5 functional key from keyboard.
F5, right?
F5. Yeah. I think it is a PowerPoint presentation. Then you can click
Yeah.
F5 from the keyboard for the full screen.
Okay. F5.
F5.
Yeah.
Okay. Is it okay? What's happening?
Or sir, you can go to your slideshow.
Yeah, the slide here. Yeah, slide is over here.
Yeah. So you can go slideshow menu. In the menu, just find it, file, home, then slideshow. You can go slideshow and make it a full screen also. Yeah, slideshow. This is the file option. I'm talking about the slideshow.
Yeah, switch.
Again, click it, sir. Click the file. Yeah.
And go back, sir.
You can see
Yeah.
the file now?
And
Yeah, I can see it, but make it full screen, sir. Slideshow. There is another
after
menu.
animation,
Slideshow.
there is a slideshow.
Oh.
After animation, you can see a slideshow.
Is it okay?
Yes,
Now
yes.
it is
You can
okay.
see the slide now, huh?
Okay, okay.
Yeah,
Yes.
now it's okay.
Okay.
Now you can continue
this-
by clicking each and every slide.
Okay, we are please. So you can hear me all right?
Yes, yes.
Yes, sir, I will hear you.
Okay, thank you very much for your nice introduction, Dr. Shungunath. So I think I'm not taking time. So I'd like to thank you, it's called the Vivekananda Institute of Science and Technology, for inviting me for this webinar. So I'm very much glad to all of you. And then I also thank you, all these participants, those who are here. So today I'd like to just to present about the sustainable energy and future electric transportation. So I think he already introduced for myself. I'm Professor Atul Rahman. Okay, now, the key points of my presentation today about the background, the electric vehicle prototype. We have developed the three prototypes. So I show you in my presentation. And the battery thermal system, impact of a battery electric vehicle on carbon dioxide emission, zero carbon ultra fast DC charging station for electric vehicle, future transportation of zero carbon transportation, sustainable energy, renewable energy, and hydrogen that will be used to charge the battery without support of the national grid, and simple tech for hydrogen generation. And you can see the potentiality of the fuel cell hybrid electric vehicle based on the hydrogen cost. Say this is the brief background. We know that the sustainable transport, it is the key capacity to support the mobility needs of a society in a manner that is the least damageable to the environment. This is very much quotation for the sustainable transportation system. And the significance of the sustainable transportation system, we'll see that it has the potential to enhance the billions of people's life and livelihoods by making employments, markets, key services like healthcare and education. So currently, the World Bank is working together with some of the countries to ensure that everyone has access to safe, efficient, and inclusive transportation system. At the same time, you can say that the United Nations, UNESCO, they're also working for getting the sustainable transportation system in the nation or in the world for the people comfortability. So you know that the current transportation system, it is a huge problem, which is get the emission about the 4% of the total emission of the world. Out of then this you can say that 74.5% of the 24% transportation comes from the road vehicles, and of course it is badly damage our environment. So you can see that the global emission, you can say that about 24.5% of the total emission. This we can cluster this emission based on the road transport, road freight, shipping, aviation, and shipping. So you can say that the road transport, normally for the road vehicle, passenger vehicle, road freight like the cargo, like the lorry, like the some others, are contributing about the 74.5% emission, which can impact our climate, sense, human health, and environment. So this is the based on this emission. This I think the one Europe they are too much voice out to control the emission and to ensure the European people that they are not getting the emission from the road vehicle. So they have planned that in the 2050 they are getting this lower emission. So they are thinking about that how they can do. So at a glance we can say that they are mainly focusing on the fuel cell vehicle or fuel cell hybrid vehicle. So based on this, they will try to get the zero emission in 2050. So the basic concept of this future transportation, innovation moving into new smart source of energy, the hydrogen, anywhere of the world, it is more sustainable energy. Everywhere you can produce renewable energy, which can get the solar and wind energy by creating the source that are systems that can capture the solar heat and the wind speed to convert into electrical energy. So modes of transport nowadays, I think people are thinking about this from 2017 to so on, about the battery electric vehicle, fuel cell electric vehicle, then you see that battery electric vehicle, fuel cell electric vehicle, fuel cell hybrid electric vehicle, and autonomous electric vehicle. So all the vehicles purpose just to cut the carbon dioxide emission. So these are the thing they are thinking. So physical and technical infrastructure, they are also thinking that how they can develop the physical and technological infrastructure that you can say the charging infrastructure, a smart technology, big data, IoT, and artificial intelligence. We already start in my research. I already start these two. It's in the technology, Internet of Things, artificial intelligence, just to control the vehicle system and to make the vehicle operation more smooth and more potential and energy efficient. So this is the first vehicle that we developed in 2012. This is the first electric vehicle in Malaysia, and this vehicle has compete with the many vehicles or many university in Malaysia, about the 20 university in Malaysia. So this is our vehicle. This vehicle get this overall champion from the Proton Green Mode Excellence. This Proton of the Malaysian car company, Giant Car Company, they arranged this competition. So inviting all these 20 universities in Malaysia, we are one of that. So our vehicle is get this overall championship. Then all other champion, we get the all other top awards, overall championship, first position of the first position of the fastest traveling, first position of the quarter mile acceleration. This is all the things. So this is the some the award we get it from the Malaysian government, about the 1 million ringgits. They access to develop the this electric vehicle. So this is my team. I myself over here, and then it's my team over here. This called this all the Union professor. He is coming from the UTM. National University Singapore. He is from this from Japan. He is also from the USA. I think Professor Walker from India. He is coming from the Virginia Tech. He is the local one. Then he also is coming from the Japan. Okay, so this appreciation that we get from our championship for all this from the Proton Green Mode Challenge, we get it the 50,000. I think they are all the things I already mentioned. Okay, this is the second one. It's called the electric transport, which is called the electric coaster. We made it for the campus commuting. And in order to develop this one, we just do the retrofitting. We get it the Mercedes coaster and the Mercedes IC engine power coaster. The IC engine power coaster we convert into electric coaster. And this electric coaster will take out all the things. Then you can place the our system. It is called the artificial intelligence powered. It's called the driveline. This is called the driveline. This driveline we can put over in the coaster. So then, but the things over here we can make it more energy efficient in terms of the energy recovery, or called break energy recovery, so that we can use the it's called the capacitor, and this capacitor used to charge the it's called the auxiliary battery. So this battery is normally used to operate the it's called the battery thermal management system. So this electric coaster will be built with this 21.5 kilowatt hour battery. It is 170 ampere hour continuous power, continuous energy delivery. Battery chemistry we use powertrain. Of course, you can make with the AC motor, peak power 44 kilowatt and torque 260 meter. Gearbox, we can take it the 2-speed gearbox, because I take out the old gearbox and put our new gearbox, so that this coaster is now operating on the campus, IIM campus, but only the problem about the charging system. So that now the battery system again, it is lithium battery, we know that it is when you discharge the high current, it is temperature is getting high or temperature spike, which is got about the 60 or more. So the battery chemistry is saying that if the temperature of the battery it goes beyond the 40 degrees Celsius, then battery will be degraded very fast, battery will be damaged and even fired. So in order to overcome this type of problem, we use the, is called the refrigerant base, R143A, a refrigerant base cooling system. So this cooling system, we can put it, this called the hollow duct, this called a rectangular hollow duct. We put it down, we say the sandwiched between the two of the battery cell, is the battery cell, is the battery cell. So that now when you pass this refrigerant to this hollow shape, this refrigerant is cooled down the plate, and the plate will take away the heat from the battery, and the heat will be out from the battery pack. So in this way, we can maintain the battery temperature is called the below 30 degrees Celsius. So below 30 degrees Celsius to make it a better temperature. So that now our battery will be get it the more it's called it the you get it the high it's called the charging cycle, its durability which increases, and then the expectation of operation will be getting more and more. So still we are using this battery, although we bought the battery in 2012. So this battery still is working with our some of the system, not with the car, because this battery is called the capacity is coming down. Okay, this is our third, it's called the project. This is very much challenging. It is called the Westport Terminal Tractor. So this tractor mainly to is called used to is called the transport the container. Is called the 20 TEU in a 20 feet container, which is about the is called the 65 tons. So these containers transport, we make it electric by using the 452 kilowatt hour battery. But this project is still running, it's not complete yet. We started in last year, but due to the pandemic, we delayed too much because we cannot go to the university. The student cannot come to the university. Then our this postdoc or some other people, they also unable to come to university. So this project is delaying. So the basic purpose of this project to reduce the carbon dioxide about the 55 tons per year, and to reduce the fuel cost about the 31 million ringgit in Malaysia. It is very much high, it's called a performance of the electric coaster that we make to achieve these two objectives. So then now we say that currently there are 460 units of the terminal TU. Terminal is called the terminal tractor operate in the campus. You see there in the over here. You can say that it's Westport terminal or Westport is called the where they can handle a lot of it's called the about the 20 something million containers every year. So that now this container we want to operate by using the electric coaster. So again, I'm saying that it is very much challenging to make it the charging station. Charging station is very much high. We needed the 500 volts. We need the 500 volts battery terminal voltage, and we needed about this 400. It's called the 450 ampere currents. 450 ampere currents. So it's quite dangerous, quite difficult to make it to the proper charging station to charge the battery of this terminal tractor. So that now cost we can get it about this about 2.3 billion procurement cost, all others, and then also future projection we can get it the carbon dioxide emission 55 tons already mentioned. The environment, of course, if you go to this place, you can see that the road is very much oily, very much sticky. So this company, they mentioned that it is due to the high amount of this carbon dioxide emission on the surface, and also the waste of the diesel. Okay, this is it's called the powertrain or called electric terminal tractor, 150 converters. We have used the battery, we have used the controller, is the motor, 500 volt AC motor, and this is the it's called the tractor. Okay, so this is the thermal management system that we make in 2012. This is the one. I told you that the main purpose of this one to put it at the temperature is called a 30 degrees Celsius to increase the battery life, to increase the battery capacity, and to increase the battery power distance to make the vehicle traction load, make the vehicle full speed, and all others. Okay, so these are things that we can based on the concept that we made this battery pack thermal run system. So this thermal run system, it has got the two patents. One patent granted, it is called the two patent already. So two patent, one patent is granted, and one is it is granted, and other one it is in filing, it's pending. So this is the two patent we get it from over here based on this product. Okay, so by using this product, I mentioned you that we get a lot of awards from our vehicle. This vehicle, it is now this vehicle is running. It's just running on the Sepang truck in Malaysia, Sepang F1 truck. So that we get it lot of advantage by using it's called the refrigerant-based thermal lithium-ion battery thermal management system. Okay, so this is the project. Is I already mentioned that is granted already one. It is also a award. There are many awards. Just I highlight one of these for British Invention Show. Okay, okay now. So I think at the beginning of this called the brief or background of my discussion, my presentation. As I said that about the 24% of greenhouse gas emission by the is called the road transport, IC engine power road transport. So now people are planning to replace the IC engine power cars by 2030 and to replace the electric vehicle. So just to reduce the 24% emission. But what about the charging station? What about the charging current? So now you can say that most of the country, they are charging their electricity power plant. It is called coal power plant, coal. Also, it is called the gasoline. Then is the hydro plant. So this hydro plant, it is the good one. There is no emission there. But other two, this is called the coal plant and the gasoline plant is very high. It's called emission level. So if you want to rely on this, we cannot say that the electric vehicle, it is eliminate the carbon dioxide emission that we get from the road transport. So now in order to overcome this problem, so we have to find the way, to think the way that how can we eliminate this call it the carbon dioxide emission 24% of all the world, and then we can use our future transport that not will depend on the power plant where we can generate the electricity. Okay, so that in that case, we proposed one of the charging station. This charging station now working. We are developing now in the IIM. So this charging station we are developing by using the solar panel. You can see the solar panel. We use the wind turbine. We use the wind turbine. Then is this wind turbine and this call it the solar panel. They will charge the battery. So battery will store the power, and then when the vehicle is come to the station, it can just connect directly to this power, and this power directly goes to the battery in the car. You can say that about this. This is our testing result. 60% battery we can charge in 15 minutes by using our this call it our charging station, our charging technology. So this is called the ultra fast charging technology for zero carbon electric coaster. So this is our flagship project. So I am leading this project. This is the flagship project. But this project I need the huge money. Some people say that it is a mega project. So this mega project, we are universities say that it is difficult at this moment to support. So then now we are looking also we are looking some of the innovative way to get the fund. It's called the crowdfunding. We're asking the people that if possible, we can support us by giving the 1 ringgit or 1 USD, even though 1 rupiah in India, so that we can develop this type of the charging station. The charging station not only for the our university campus, we can do it for the national EV charging infrastructure development. We can also make this one for the defense industry, different organization, like the golf resorts, where the lot of electric vehicle, so that if they use our system, they have to reduce this number of vehicle, number of it's called the golf carts. So this then some other company, they are using this electric car for the inverse for this their business purpose. They also will be benefited from our technology, which can charge their electric vehicle battery, and to make the vehicle is called our main concern is to make it the zero carbon, because over here we're not getting any power from the electrical power plant. This power is automatically generated by using the solar panel and the wind turbine. So the concept over here, if we use the wind turbine, solar panel, we can solely depend on the solar heat trapping. But if the cloudy day, we cannot get any electricity. So in order to make the continuous power delivery, continuous charging operation, we can use the wind turbine. So this wind turbine, if you operate more than 2.5 meter per second with speed, then of course you can get it the high electrical power, about the 6 kilowatt. 6 kilowatt power is good enough to charge the battery. Even if this one operate without this solar panel, it need to charge about the 300 ampere hour, it means that about 40 ampere currents. So getting about the 7 hours. So that now if we operate all over the day, 24 days, because 24 hours it can operate. There is no restriction. We don't know that when the what time of the day we get the wind speed is more than 2.5, or time the wind speed coming is below 2.5. But average, we're expecting that the wind speed is coming more than 2.5 meter per second. So in Malaysia, from our new survey, we can get it the wind speed about the 3.5 meter per second. So that I think this technology that we use, we can charge the battery very easily without support any of the system, and then we can charge our electric car, or the electrical battery with this clean energy, where there is no carbon dioxide emission. So we can say that the future transportation that we can get in the market is called the zero carbon transport. Okay, so this is our basic concept. So we are working for this. We hope that this project will be finished by the 2023. We start already, but due to the pandemic, we cannot do anything. Our university completely closed. Nobody can go there because university all around is called coronavirus infected person. So that we are restricted to go there. That's why our project is delaying. Okay, so the next one, the new vehicle now. We can say that for this electric vehicle, we know that there are some problem that we know this before. You can see there for the electric vehicle, battery electric vehicle, which is called the BEV, the battery electric vehicle. So this vehicle, it is very difficult to run, operate for longer mileage, because I know it, I developed the 3 vehicles, I know it. It is very difficult. So in that case, we need the high capacity battery. For the passenger car, at least we need the 66 kilowatt battery. So if you use the 66 kilowatt battery for the 200 kilometer traveling, the battery vehicle weight increases about the 1000 kg. So that you can say that the battery itself is consuming the power. And then only you can go this 200 kilometers. We cannot go more than that. Other than that, it is getting the next problem we get it from there is called the charging time. Charging time, we get it 5 to 10 hours for full charging. At full charging 10 hours, for the 5 hours, you can get about the 50 to 60%, 50 to 60% charging. But we have to wait for the 5 hours. Then who has the time to wait on the road? Nobody has time. Everybody is rushing. So that now, in order to overcome this problem, we are also thinking about this DC-DC charging system. And then only the 200 kilometers you have to wait for this. So that now, other than that, we can get it the battery recycling. After the battery used for 5 years or 6 years, is called the 2000. This is called the charging cycle. 2000 charging cycle, battery will be finished. So battery will be gone. So that now, in order to overcome this problem, we have need to battery recycle. But now we want to invest $1 million USD just to develop the recycle plant of the battery. And the output of the battery but from the recycle plant, from the recycle materials or recycle product, we not get the high amount. We not get the values that more than the cost that we incurred for the battery recycling. So then now, in order to overcome both of the problem, we now, I think people are thinking about it, about this fuel cell vehicle. We can see the fuel cell vehicle now, Toyota Mirai, they use it. This fuel cell vehicle. But the problem is, they say that this fuel cell vehicle, they can go about the 500 kilometer by call it the single refueling of the hydrogen. But the problem is, they also mentioned that it is for the traction power. Traction power, they are not getting very high. They are saying that the traction power is getting by the vehicle is called the regenerative braking mode. But regenerative braking mode all the times cannot get the high amount of the battery power to cover the traction power. So that now, and other than that, fuel cell is almost in constant drive mode. It cannot go more than that. Whatever the fuel it's called hydrogen supply increase in the fuel cell, because fuel cell has a capacity, constant capacity, or the specific capacity. It cannot go beyond that. So that now, and other than that, this fuel cell is not potential in the city drive, because city drive, this car can go and stop. So when you go, car stop and start to go, then car need the high, is called the acceleration power. High need the traction power or acceleration power. Traction power or acceleration power. So that now, this fuel cell, I mentioned that it is unable to develop the traction power. So the now, in order to overcome this traction power, we have to find the alternatives. And also this, the advantage that we get, it is a shorter charging time, like the petrol refueling of the car. So then now, in order to overcome this problem, so people are thinking, we're doing the work on this project about this